We are going to verify trig identities. We will use many of the same strategies and substitutions that we used for simplifying trig identities, but we're not always simplifying. We are just manipulating the expression so that it ends up looking like a different expression. And we are told what we want to make it look like. And I have 3 examples planned for you. Example 1. So here we're given an identity, and we are asked to verify it. That means prove, using algebra and substitutions, showing all of our steps, that one side of this identity is equal to the other. You have your choice if you want to start with the left side of the identity or the right side of the identity. In this case, it looks like I have a little bit more I can do to manipulate the left side. So I'm going to start with the left side of this identity. Notice that what I want to manipulate it to look like includes a cosecant of x. So I want to keep one factor, one cosecant of x, which is why I'm going to start by factoring it out. Instead of cosecant squared of x, I separated it to cosecant x times cosecant x. I want to keep one of those for my final result. The other one I can replace with a reciprocal identity. And the cotangent of x can be replaced with a quotient identity. So I'm keeping one of the cosecants of x. I did a reciprocal identity for cosecant of x and a quotient identity for cotangent of x. Next, we will use some algebra and multiply by the reciprocal. That will allow us to simplify, giving us cosecant of x times 1 over cosine of x. Don't forget to pay attention to what we're trying to end up with. We're trying to end up with cosecant of x times secant of x. We have the cosecant of x. If I use a reciprocal for 1 over cosine of x, I end up with the other side of the identity. And ultimately, I have proven that the left expression is equal to the right expression, meaning that this identity is true for any angle value for x. Let's look at example 2. Definitely, the left side of this identity has a lot more for me to work with, so that's where I'm going to start. And I'm writing small this time because this one has a lot of steps. The first fraction has a denominator that wants to be a Pythagorean identity, but it's not because the secant is not squared. We can make it a Pythagorean situation by multiplying the numerator and denominator by the conjugate. When I do that, the denominator becomes 1 minus secant squared of theta, and I will be able to do a Pythagorean substitution. But be careful. Let's look at that Pythagorean identity. I would have to subtract secant squared from both sides and subtract tangent squared from both sides in order to find the correct substitution. So in that first denominator, I am going to replace 1 minus secant squared of theta with negative tangent squared of theta. Now I can simplify the numerator with one of the factors in the denominator. And in this next step, notice how I put the negative sign in the numerator instead of the denominator so that I would have like denominators. Now that I have like denominators, I'm going to add the fractions. I also distributed that subtraction into the first numerator, which allows me to simplify to 2 secant of theta. Secant of theta plus secant of theta is 2 secant of theta over tangent of theta. I can use a reciprocal to replace secant of theta, and I can use a quotient identity to replace tangent of theta. Once again, I'll use algebra to multiply by the reciprocal, simplify, and look what we want to end up with. A cosecant of theta following the 2. We have that when we replace 1 over sine of theta with its reciprocal. So again, we have shown that the left side of the identity is equivalent to the right side of the identity. One more example. However, we can do this one 2 ways. I'm going to do this one 2 ways for you. You're getting an extra example at no extra charge. Because it's hard to decide. You kind of have a choice here if you want to start with the left or the right. I'm going to start with the left the first time. I can use a quotient identity to replace cotangent cubed of t and a reciprocal identity for cosecant of t. Using algebra, I will multiply by the reciprocal, and I can simplify sine of t with one of these factors, sine of t. That leaves me with sine squared of t in the denominator. Okay, so this is what we have. Notice that I want to end up with a cosine of t in my final result. Like I did earlier, I'm going to factor out one of the cosines from the numerator and keep that. I do not want to lose that. Now I can use a quotient identity to substitute. And if you pay attention to what we want on the left side, I am going to look at a Pythagorean identity to find a substitution for cotangent squared of t. And it's exactly what I need. We have proven that the left side of this identity is equivalent to the right side of the identity. What if we took that same identity and we started with the right side? I have an interesting little strategy that we may or may not have used before, but it's good to know. I'm going to start with a Pythagorean substitution. But notice on the other side of the identity, I want cotangent cubed. And right now I only have cotangent squared. We can manipulate and get a cotangent cubed as long as we multiply by a fraction that's equivalent to 1. Cotangent of t over cotangent of t is equal to 1. But when I multiply, it gives me a cotangent cubed in the numerator. Don't turn around and simplify right now because you'd be going backwards. We want the cotangent cubed of t for our final result. I don't want to change that anymore. What I do want to change is cotangent of t using a quotient identity. Multiply by the reciprocal. Simplify. And remember, I want to keep the cotangent cubed of t. That's in the left side of the identity that I'm trying to end up with. I can replace sine of t with 1 over cosecant of t, and look what we have. We have made the right side of the identity equivalent to the left side of the identity. We're being very manipulative with verifying trig identities.